subscribe, share and like our video. Now let's continue our topic. In our previous lesson, we are discussing about heat. It is a form of energy that flows from higher temperature to the lower temperature when two bodies are in thermal contact with each other. The amount of heat that flows from one body to another is called the quantity of heat. So quantity of heat, it is the amount of heat that flows from one body to another. And the quantity of heat, it depends on three factors. It depends on three factors. These are the first one, mass of substance. The second one, temperature difference. And the third one, type of substance. The first one, mass of substance. Mass of substance. How it affects the quantity of heat. As an example, let's take two cases. The first one, 1 kilogram mass of water, H2O, and the second one, let's take 2 kilogram of water, H2O. Now both heat at the same temperature, 100 degrees Celsius. Again, the second one, 100 degrees Celsius. Here, both substance the same, type of substance constant, temperature again constant, but mass different. When you compare the quantity of heat for these two cases, the quantity of heat is directly proportional to mass m, which means when mass increase, it takes more energy or more heat. When mass decrease, it is less energy. Therefore, quantity of heat, which is denoted by Q, depends on mass. This is our first case. And the second one, let's see an example. If we take 1 kilogram of H2O, again here 1 kilogram of H2O, both have the same mass and the same kind, but when we heat first one at 100 degrees Celsius and the second one at 70 degrees Celsius, temperature increase, quantity of heat will increase. When temperature decrease, quantity of heat decrease. From this, quantity of heat again directly proportional to change in temperature. Let it be our second equation. Now compare these two equations. So what do we have? which is type of substance. In this case, let's take 1 liter here, 1 liter here again. Let's take 1 liter mass fixed, and also heat at a temperature of 100 degrees Celsius, the first one. Second one at 100 degrees Celsius, temperature constant. But if the first one is water, H2O, and if the second one is a substance which is different from water, or we can take oil, the same mass, the same temperature, but if different substance, it will take different heat. So quantity of heat depends on type of substance. From the above expression, the quantity of heat is directly proportional to mass and directly proportional to changing temperature. There is a proportionality constant. There is proportionality constant, which satisfy the equation Q is equal to mass times C times changing temperature. This C is the proportionality constant. The mathematical meaning for C, it is a proportionality constant, and the physical meaning of a specific heat capacity is type of substance. Hence, the specific heat capacity C, this implies that C, which is specific heat capacity, is equal to quantity of heat divided by mass times changing temperature. Now, let's define the specific heat capacity. Specific heat capacity, it is denoted by capital C. So it is energy required to change or to raise the temperature of temperature of 1 kilogram mass by 1 Kelvin. And the unit for specific heat capacity is the ratio of the unit of quantity of heat, which is Joule, SI. Unit of specific heat capacity is the ratio of the unit of energy, which is Joule, per kilogram per Kelvin is the unit for specific heat capacity.